Okay, welcome back, students. So we're going to read this very carefully for understanding, and then we're going to draw something out, and then we're going to calculate it. Okay, so the area of the square drawn on the hypotenuse of a right angle triangle. What's that comma doing there? This is a right angle isosceles triangle. I'm not sure what that comma is doing there, and I think it threw me on my first reading. Is 24 centimeters squared. Work out the area of the square drawn on each of the other two sides. Okay, let's model it over here in the camera. Okay, so now draw a nice big triangle to help us think. Oh, maybe I went too far. Will it stay on the page? So that's a right angle. Don't have to be perfect like this. I could sketch it, but you know, it's a bit of a challenge, this question, so at least if you haven't done it before. So I'll just do a decent enough job. We're going to go off the page slightly here. That's fine, and but we do know we're coming across here, so we'll be able to get the sense of this square. So this square here is 24, is it, or 25? 24. So the area here is 24. We use square brackets for area. So we have another square down here and another square out here, gone off the page out here where my hand is. Okay, so 12 and 12 obviously, because it's an isosceles triangle, and you know, and this is very, very famous in terms of 1 is to 1 is to root 2. But in the sense of area, remember what we said today? If we write these as squares, then you can see the ratio of the areas, okay, which is 1 is to 1 is to 2. Okay, we keep going. Let's look at it on the nice writing first. So the given television has a rectangular screen with a diagonal of length 74. Okay, we want to start drawing, interacting, so let's go to camera here and get my straight edge. The given television has a rectangular screen with a diameter of length 74. Okay, so if we're going the way the one in the log table is arranged, it's looking like this. The sides of the screen, oh, this is nice, are in the ratio of, so 5 is to 3. Obviously the screen is longer this way to this way. Okay, so what we work out the length of these sides in centimeters, correct to one decimal place. So this is a scaling situation. So what we'll do is we will work our way through this slowly and figure things out as we go along. So we're going to have, let's call that the small triangle and call this the big triangle. Okay, so in the small triangle we have, this is called mathematical modeling. It's progressing the question forward, having a sense that maybe I know what I'm doing, but it's about moving forward and applying what you know. So let's do some problem solving. We have, we'll go to the calculator, but we'll just write it here to 5 squared plus 3 squared. Okay, so go to calculator and we're going clear root. Have a look at that. Of course, it's root 34, I think, and that's the baby here. So the question is, how does 74, so this is a direct proportion, 74 is to square root of 34. That's the actual triangle to the baby model. So why did we use 5 and 3? Because they told us the ratio is 5 is to 3. So we could say, okay, let's make it 5 centimeters and 3 centimeters, making this root 34 centimeters. So this is a real number if I divide them in, which I will. But I already have root 34 here, so I'm missing a trick if I throw that away and start again. So given that I have this, I'll divide it by 74. No, you know what, I could go now with the 74 upstairs and the answer downstairs, but this answer button is just a little risky. So rather than risk that that went in right, I'll just do the work and put 74 over root 34. And we can I don't need to shift equal when it's going to be irrational anyway. Oh no, it's okay. So yeah, you could shift equal as well. So that really doesn't tell us a whole lot. Well, it does. It tells us what we're to scale down. What are we looking for? The lengths to the side. So we want to divide that. Hold on. Okay, let's go back to the drawing. Okay, let's look at it as a real number. It'll just give us a better sense of what's going on here. So the television itself is 12.69 times bigger than a little square, a rectangle with sides 5 centimeters and 3 centimeters. Now that's in length, so we're scaling 12.69 in length. So basically we'll multiply that 5 by that and 3 by that, and we'll get the other length. So great. Now because I'm going to be using this twice, I'm going to store it to A. Okay, and now I can say, hey, what is 5A? And I'll shift equals it. I get, by the way, I don't have to shift equals it. I can also look at it the other way, but it's not giving it to me. So that's fine. It's 63.45 centimeters, is it? Centimeters wide. Yeah, and then the other one is 3 of them. So I can go back here and edit that into a 3. And equals or shift equals, and it's 38. Now how many decimal places? 1 decimal place is, and notice, yeah, I wrote enough down there so I don't have to go back. 38.1 tall and 63.5 wide. Okay, and they'll have centimeters and centimeters. Oh, come on, let me give my answer nicely, because I'm about to check the answer. 63.5 centimeters, 38.1 centimeters, and this is one of these ones where maybe we do want to look at the answers. Okay, so question 16, 63.5 and 38.1. That was a challenge, question 16. And we're on to question 17, last question in this section. Explain why a triangle of sides is not right angled. Okay, so identify the longest one, and we will compare the square of that. So when you're comparing squares, you're not writing equals because it's going to end up being bigger, but you're putting a squiggle to say you're investigating. How does that compare to this? Okay, so we all know 18 squared is 324. No, we do not. 18 squared equals 324. Now we all know. Okay, 12 squared we know is 144. 13 squared, trick here, double the 2, square the 2. Trick here, double the 3, square the 3. It's just an accident of expansions. When the numbers are low, there was no carry. Okay, so they add up. Well, if I'm going to add them at all, I'll go back to square one and take no risks. And we simply say 324 is not, so this was always going to turn into either is equal or is not equal, and 324 is not equal to 313, which implies that triangle 12, 13, 18 is not right. We know how to say it is not right angled. Okay. Perfect. Look at that. 18 squared. That's even nicer. Look at that. That was pretty. Okay, that's the end of them. As always, we'll see you in the next one, which will be driving on as far as 22.2. Okay. Stop the video. See you in the next one.